Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at behavior at zeros. When we find the zeros for a polynomial function, we need to know how the graph behaves close by to those zeros. Does it pass through? Does it turn around? And so in this video we're going to talk about all the different scenarios that you might face. First, if a zero has a multiplicity of 1, meaning that it's a factor only one time. For instance, if we had a function f of x equals x minus a times some other factors, a would be a zero of multiplicity 1 because x minus a is only a factor one time. When there's a multiplicity of 1, either the graph passes through moving upward from left to right, or it passes through moving downward from left to right, but there's no change in the shape of the graph. And when I talk about the shape, I'm really talking about concavity. Concavity is whether it's concave up or concave down. That comes into play when we get to odd multiplicities that are greater than 1. So let's say we had another factor like x minus b, and that was root 3 different times. Either it's going to look something like this, down from left to right, but changing the way it bends. See how it's kind of concave up on this left side, but it switches to concave down on the right. That's called an inflection point. We'll talk about that much later, but it's a change in the concavity. The other, it could also be moving upward, so you could see something like this, for instance. Now, if there's an even multiplicity, meaning that the root is a factor twice, 4 times, etc. So let's say we had x minus c squared. Then in that case, the graph turns around at that point. So it could look something like this, or it could look something like this. So if the multiplicity is odd, it goes through the point. It doesn't turn around. It's just whether it changes the bend to the curve or not. If it's an even root, then it always turns around at that spot. So in this example, we want to look at the behavior at each zero. Underneath in red, I'm going to write the multiplicity for each of these. So we've got a factor x. That's got a multiplicity of 1. X minus 3 squared, that's a multiplicity of 2 because it's squared. X plus 2 is back to a multiplicity of 1. X plus 5 has a multiplicity of 3, and x plus 8 has a multiplicity of 6. So for behavior, the 0 and negative 2 are two roots that have multiplicity 1. And that means that the graph passes straight through. So I've taken care of that one and that one. X minus 3 squared, so that 0 is 3. Its multiplicity is 2. And the graph is going to turn around at that root. X plus 5 to the third power, so negative 5 is a root whose multiplicity is 3. And so I'm going to write passes through and bends. So it's either going to change from concave down to concave up or up to down as it passes through that point. Finally, the last one, x plus 8 to the 6th power, so that root is negative 8. The multiplicity is 6, and the graph will turn around at that point. So these are parts of the pieces of the puzzle that we need to know when we're trying to graph a polynomial function once it's been factored. Then we add in other things like its behavior at the two extremes, what we call end behavior. Besides the x-intercepts, what is the y-intercept? And then we try to piece all that together to sketch the graph from there. All right, that's it. I'll see you in the next video.